Okay, we're going to solve equations today in one variable, a lot of rational equations, but some problems with application and some other types of solving equations. Okay, so we first need to get things factored when we have equations with fractions, because we want to clear fractions, but we need to find the least common denominator first. So this right here factors into x plus 3 and x minus 1. So imagine that's right there. In fact, I'll just erase it and write it there. Save space. That's the same thing that was there, only it was FOILed out. So now we can multiply it in clear fractions. So we'll multiply through by x plus 3 times x minus 1. And that we have to do that to everything when you clear fractions. And then you can simplify. So this x minus 1 cancels, and I end up with x plus 1 times x plus 3 in the first term. This x plus 3 cancels, and I end up with negative 9 times x minus 1. And then this whole denominator cancels, and that just ends up being plus 8. So by multiplying through by the least common denominator, we clear fractions, and we end up with a quadratic in this case. We need a FOIL. And then distribute. And then just simplify. We're going to get things in standard form. So 9 plus 8 is 17. And we need to add 9x to both sides and subtract 17 from both sides. And that gives us x squared plus 13x minus 14 equals 0. We want to solve this now. I'm not sure that it factors. It doesn't look like it does. So unfortunately, we're going to have to use the quadratic formula now. Opposite of b, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. Okay, double negatives go positive, and this whole thing then simplifies to 225 if you do it in your calculator. So you have negative 13 plus or minus the square root of 225 all over 2. But the square root of 225 is just 15, so this would be 15. We have negative 13 plus 15, which is 2 over 2, which is 1. And we also have negative 13 minus 15, negative 28 over 2, which is negative 14. So we have 1 and negative 14. Now, 1 does not work. And the reason we know 1 doesn't work is because if you plug in 1 right there, you're going to get an undefined value for your answer. So we need to try negative 14. And I know it's a lot of work to plug in negative 14 to check that it actually works, but unfortunately you're going to have to do it. Gives you negative 13 over negative 15 should equal negative 9 over negative 11 plus 8 over negative 14 plus 3 is negative 11 times negative 15. So we have 13 over 15 on this side, and then 11 times 15 is 165. So we have to try to add these fractions. I'd just pull out a calculator, I guess, and see if these are equivalent at this point. And they are. They both equal 0.86 repeating. If you pull out your calculator, just add these together. So that does work. I know it's a lot of work to check, but it turns out that the first one was extraneous, and this one was a solution. So we need to make sure we specify that once we get these answers. And I really should say that these were solutions for x in this equation. Once again, same thing. Make sure you factor. So it's x over, I'm going to factor out of 2. That gives me x minus 2. And then I need to multiply through by the least common denominator, which in this case is 2 times x minus 2. And that needs to be multiplied through by everything. So the 2, sorry, I didn't mean to write an x there. This whole thing cancels, and I get just x. And then this would be 4 times x minus 2. And then this quantity cancels, and I just get a 2. So now I set up with a linear equation. X minus 4x plus 8 equals 2. That'll be negative 3x. And if I subtract 8 from both sides, it gives me negative 6. So x equals positive 2. We do need to check to make sure it works, and that is undefined, because it gives me undefined in the bottom. So there'll be no solution. This solution right here is extraneous. Okay? There is no solution. Problem 3 then is a little bit easier. 1, I can multiply through by 3x is the smallest thing that everything in the bottom goes into. The x's cancel. Negative 21 equals, this cancels, so you get 10 minus 3x. Subtract 10 from both sides. Negative 31 equals negative 3x, so x equals 31 over 3. And obviously don't forget to check it, but it should work in this problem. I don't see any undefined values, but just make sure you check it to make sure that it works in these problems. All right, same thing here. Multiply through by the smallest thing that all the things in the bottom go into, which is obviously just x. All right, it gives me x squared, and then these x's cancel, plus 1 equals 2x. Get this polynomial in standard form by subtracting 2x from both sides. And then try to factor if you can. X minus 1 and x minus 1 actually works to factor this. So the solution is x equals 1. And that should work here. If you try 1 plus 1 over 1 equals 2, that's true. So x equals 1 is the one solution. Okay, another one of the same type of things. This is a difference of 2 squares, so it factors into 3 minus t, 3 plus t. And so keep in mind, that's going to be our least common denominator because there's the other factors right there. So we're going to multiply through by that, 3 minus t, 3 plus t. And it does help to write this out maybe a little more clear than what I'm writing it out on scrap paper. I'm multiplying through by that to everything. In the future, it does help to write the whole thing out. So 3 minus t is canceled, and you get 2 times 3 plus t. 3 plus t cancels, and you get just 3 minus t times 1. And then the whole bottom cancels here, so you just get 1 equals 0. So we can distribute 6 plus 2t plus 3 minus t plus 1 equals 0. Add like terms together, so 6 and 3 is 9. I'm sorry, plus the 1 is 10. And then 2t and negative t make t equals 0, so t equals negative 10. And you want to try that to make sure that it works in here. This should be the solution if you plug it in. All right, here's one that's a little bit more difficult. And we're going to need to factor this bottom. Now, if you see this, typically they're giving you problems that you can clear fractions with, meaning that the number that you have to multiply through by is usually a decently easy number, which means that basically this should be a factor of this one because our least common denominator that we multiply through by, we need it to be small enough where it's going to work. So I'm guessing that this thing factors 3x plus 4 times another linear factor. And that linear factor is probably the other one, 2x minus 1. Let's just check that to make sure that it works. First term's good. Yeah, that's the right factorization. So turns out that this polynomial is just the linear factors of these two. So we can multiply through now to clear fractions by this or this. 3x plus 4 times 2x minus 1. It does really help to write this out and maybe write it slower and more clear than when I'm writing it out. It just helps you not make mistakes on a test. It's better to spend that amount of time than the time you would need to go back and try to figure out what you did wrong. But you can cancel these out, and you get 2x minus 1 plus 6 times 3x plus 4. I'm sorry, both these factors cancel, so it's just plus 6. And then you have x times 3x plus 4. So clearing fractions makes a complicated rational equation into a simple linear or quadratic. This is plus 5 equals 3x squared plus 4x. I'll move everything to the right. So I'll subtract 2x from both sides and subtract 5 from both sides. Gives me 0 equals 3x squared plus 2x minus 5. And I don't think that factors, so I'll just use the quadratic formula real quick. Opposite of b plus or minus the square root b squared minus 4ac all over 2a. Double negatives go positive. We have 12 times 5, which is 60. Square root is 64, so this would be 64. And the square root of 64 is 8, so it's 8 So -2 minus 8 is -10/6. It's one of our solutions. And -2 plus 8 is 6/6. So 1, and this simplifies to -5/3. So -5/3 and 1. And we want to try both of these. Both of them might work, actually. So we're going to want to check both of those. I know it's a lot of work, but you are going to have to check those. Or maybe just enter them in and see if it works. And if it doesn't, then unfortunately you're going to have to go through the process of checking to make sure that one of them is not extraneous. All right,